In this video, we want to introduce the concept of antiderivatives, alright, which a lot of people call integrals. Okay, so by antiderivatives, which is the integrals we mean the anti of differentiation, alright, so more like a reverse operator of integration of differentiation. So if you've taken a calculus class, okay, you probably know, of course you have to know what it means to talk about differentiations, alright. So you know the symbol, well, the derivative with respect to maybe x of a certain function of x. So to introduce it quickly, I'd like to maybe bring in this function x squared plus 1. Okay, so we want to integrate a sum of two functions. We say that the derivative of the sum is the sum of the derivatives. That is to say, you can take the derivative with respect to x of x squared, okay, and then you now add it with the derivative with respect to x of 1. Of course, when you have a power function like x to the power 2, okay, to differentiate that is x to the some power, okay, when you differentiate this with respect to x, okay, that means we're going to have, well, you're going to bring the power down, that will be n, you multiply it by the x that was there originally, okay, yeah, and then you now subtract 1 from this power, that will be n minus 1. Of course, so we're going to do that here. That means we are going to have, well, we'll bring these two down using that rule right there. That will be 2. We put down the x which was originally, and then we're going to subtract 1 from the initial power. So you subtract 1 from 2, we're going to have just 1. Alright, then we add it with, well, when you differentiate a constant, you're going to have 0. You can use this, it still works out. So this is going to give us 0. So altogether we're going to have 2x as a result. And I don't want to do a lot, but if you differentiate just x squared, you're going to have 2x. If you differentiate x squared plus any other constant, let's say plus 10, once you differentiate a constant, you get 0. The result will still be 2x, alright? So by antiderivative, we use this symbol, the elongated ace. Well, the antiderivative ensures that when we integrate the result, that is when we integrate this 2x, which is the result of the differentiation, or integrate it with respect to x, or you can say over the x variable, we will get back to something like this, alright? We'll get back to this. So in this case, since we know that 2x came from x squared plus 1, that means that this result is going to be x squared plus 1, isn't it? But remember what I said, that even if we differentiated x squared only, that is x squared plus 0, the answer will still be 2x. Even if we differentiated x squared plus 3, the answer will still be 2x. So we cannot be sure of this one. So instead we say x squared plus some constant, alright, where this constant can be any number, maybe in the real numbers. Good, and this is a good way to go. So in our next video, we are going to explain what really went on here, maybe using a rule that looks like this, but for antiderivatives, which we call integrals, alright? And I've already explained the concept of this arbitrary constant. So we'll continue from our next video. Alright, thanks for watching. Please share this video with your friends. Okay, in this video, we want to jump right into learning how to integrate a power function. Alright, so in a previous video, we talked about from differentiation, okay, differentiating anything of this form, you're going to have 2x. Therefore, as an antiderivative, which we can use this integral sign to do, the integral of that result, that derivative will give us the original function. So just watch the previous video before you get to this one. Alright, okay, great. So we really want to know what happened over here. Well, just like we have that the derivative of a power function, okay, in terms of x, with respect to x is going to be n, then x raised to the power of n minus 1. We are going to do a similar thing for the integrals, but they are not going to be the same, right? Just, this is a rule for when you are differentiating. The one for integrals is called the integral rule, that is an inverse power rule, right? Okay, great. So we're going to have the integral. Well, if we have any power function, let's say x raised to the power n, alright, and for the sake of this example, I'm going to use a constant. So let's just say any a, where a is just any number, for example this 2, right? Then we have to do that over the x variable. Well, this is going to be, put the a, then add 1 to the power. So we're going to have x raised to the power of n, we add 1 to the power, and then we divide by the new power, which is n plus 1. So that is how it's going to be. Then remember, from what we discussed earlier, that we're always going to be adding an arbitrary constant. And the constant is because once you differentiate this plus any constant, the result stays the same as if no constant was there, no matter the constant, because the derivative of the constant is going to be 0. So that's the reason why we will always add an arbitrary constant. whenever we are taking an antiderivative like this. All right, so this is the formula we're going to use for this one. Okay, so I memorize this formula, and in the next video we're going to apply it right here. Okay, thanks for watching. Please share this video with your friends. Okay, in this video we're actually going to learn how to integrate this function, all right, and we'll also be sure that this is going to be the correct answer for that. I'll be using this rule here, which is the inverse power rule. All right, when you have a power function, this a is just a coefficient, just a constant, like just a number like this two. This n also is just a number, any number. Okay, like here we have it to be 1. Well, this is going to be that. Okay, so let's apply the rule in solving this question right here. So we have the integral of this. Well, notice that this is the a, you can call it the 2, so the answer is just going to be 2 outside. All right, then we are going to put x up here. This is n plus 1. Where was n? N was the power of x. So the power of x here is of course 1. So we are going to add 1 to the power of x, which was 1 originally. All right. And the next thing is to divide by the new power, which is 1 plus 1. All right. Okay, when you're done, you're going to add an arbitrary constant. Always remember that whenever you're doing antiderivative, or you can call it integral, right? Always remember to add the arbitrary constant. This is an indefinite integral, so that is true. Okay, so we have 2 here. Well, 1 plus 1 is going to be 2. That is x raised to the power of 2. We divide it by 1 plus 1, which is also 2 in the denominator. Notice that this and that will cancel each other out. And of course, you don't forget the arbitrary constant c. So we are only left with x squared plus c. And this is exactly what we were talking about, isn't it? That's very nice, all right? Okay, in the next video, we are going to solve more examples using this inverse power rule. All right, thanks for watching, and I'll see you in the next video.